3 pages on it, all right? They're all 3 unique pages. I've already covered the material for the middle page, all right? That was expected value. How did we find expected value yesterday? What was the shortcut? The N times the P, that's correct. The number of trials times the probability of success gives me the expected value. So the middle page, in just a little bit, I'm going to give you some time to do that. The middle page is that idea there, all right? So we're going to do N times P. There's a couple other concepts that I want to show you real quick as well. All right, so here's where we are in our notes. We have a box, and in that box, a large number of carnations, of which 1/4 are red. All the rest are white. Carnations are picked at random from the box. How many flowers must be picked so that the probability that there is at least one red carnation among them is greater than 0.95? All right? So this one's a little bit different. It reads a little bit different. All right? What's different about this? What don't I have in this one that I normally do have? I don't know how many trials. That's correct. I'm going to keep picking out flowers until I get this to happen. All right? And so what I want in this problem is I want it to have at least one red carnation. All right? So if I went there to start, I'm going to set up a probability tree to start this. So I could get a white and I could get a red. All right? And get a white and a red to start. So if I pull one out, all right, what's the probability that I get a white, and what's the probability that I get a red? 3/4 and 1/4. That's correct. All right? So 3/4 and 1/4. Okay? So I have that there. Now, the next one, if I went again, I'll do that again. I could pull another white, or I could pull a red. All right? There's so many of them in this container that the probabilities are the same, basically, is what it's saying. And so this would be 1/4. This would be 1/4. This would be 3/4. And this would be 3/4. Okay? So what it's asking is this. If I were to do this, what is the probability, or how many flowers must I pull out so that I have at least one red has a 0.95 or 95% chance of being happy? All right. Well, what is it that I don't want here? All whites, correct? So I don't want to stay. The path that I don't want to take is I don't want to take that path right there. Okay? All the other paths will lead me at least to one red. Everybody good? Okay? So now here's the thing. What I don't want is I don't want 3/4 to some x power. So this would be 3/4 to the 1 because I picked one flower. That would be 3/4 to the second power because I picked 2 flowers. Keep on going. All right? This is the piece that I don't want. So I'm going to go 1 minus that piece right there. That's going to give me the probability that I want, and this probability right here has to be greater than 0.95. I'll let you kind of digest that a little bit. It's a little bit different thinking. All right? This 3/4 to the x is all whites. I pick nothing but whites. I don't want to pick nothing but whites. So 1 is everything minus the piece that I don't want, and I want that probability to be greater than 0.95. Okay? How would we solve this? You got your calculator, you can just go plug it in, correct? All right. If you have your calculator, we can go graph it. I'll do that here in a second. If we didn't have our calculator, then I would probably subtract 1. I'd go negative 3/4 to the x is greater than negative 0.05. All right. There's a negative here and a negative there, but what happens if I make them both positive in this case? Somebody says, yeah, I got to flip the symbol, all right? So 3/4 to the x, flip the symbol, 0.05, and now I can do my log. So I'm stuck here in exponential form, and I can change the log form. So log 3/4 is my base, 0.05 is there. and that's going to equal to x. So that would be the number that I'm looking for, all right? So I'm going to go to my calculator now, and I'm going to put that in the calculator. So if I were to go to the calculator, if I was just on my home page here, actually, let me just start fresh. On, new, no, I'm not going to save that. If I just, on a calculator, I can go Control Log, and I can say 3/4 is this down here, and this is 0.05 there, and so that gives me 10.1. Okay? Now, or excuse me, not 10.1, 10.4, all right? But I can't have 10.4 turns. So this would be 10 turns or 11 turns. Which one? 10. I need at least, right? So I need to go to the next one. I need 11. I need the 11th pull. The 10th pull is going to be a little bit under 95. Now, sometimes it's easier to look at the picture of this. So if I were to do this, Control Doc, I'm going to go add a graph. The first one that we had was this, 1 minus 3/4 to the x. So there's that graph right there, all right? The other one, I'm going to hit tab. The other thing I wanted was 0.95. I wanted to at least be that. Now you see this is a really flat line. I need to go find where they intersect, all right? I'm probably going to need to increase my graph over there. I'm going to go Menu. I'm going to go Window Zoom. And I'm going to change my window settings. So I'm going to go out to 20 for the X max. You might want to adjust this a little bit. I don't need to be quite 6 tall. I only need to be like 1 tall, so I'm going to change it to 2, just so it zooms it in a little bit more. And now when I do that, I kind of see where it's changing, all right? I want this to be greater than 0.95, which is right there. So that's equal to there. So if I were to go find Menu, Analyze Graph, and I go find my intersection, I work left and I work right, I get that same answer that I just got. I got 10.4, all right? But now you see the blue line, it's greater than after that 10.4. So I got to go to the 11th pull. So if I pull out 11 flowers, then I've got a 95% chance that I have a red one. Red ones are my wife's favorite. I have to have at least one of those to take home to her. If I have all white, she'll be disappointed. Okay? Good? All right. So that idea, this idea right here is on that other page. Is on the first page of the homework tonight. All right? On that first box. Okay? Now, one other concept. And I'll walk around and help if you need some help, but we're going to do some problems here in a second. The binomial distribution, that's what we've been working on the last couple days, where x is binomial distributed and n is the number of trials and p is the probability of success. All right? We talked yesterday about finding the expected value, which is kind of like the mean of the problem, and that's n times p. There's another equation on your formula page. All right? The other equation on your formula page is variance. Have we talked about variance before? What is variance connected with? Anybody remember what variance is connected with? Standard deviation. Variance and standard deviation went together. All right? If you take the square root of variance, then you get standard deviation. Or vice versa. If you square standard deviation, you get variance. So I have a way to find variance here. Variance is n times p times q. Well, the n times p looks familiar. That was yesterday. What's the q? The q is the complement here. It's the opposite of p. All right? So it's the probability of a failure, basically, is what it is. P is the probability of success. Q is the probability of failure. So I can find my variance using this formula here. So let's take a look at an equation or a problem. All right? This one's in your notes as well. All right? In a large company, 40% of the workers travel to work on public transportation. A random sample of 15 workers is selected. Find the expected number of workers in the sample that travel to work on public transportation, and then find the standard deviation of this. Okay? So if I were to do that, expected value is n times p. Do you have n? Yes, what is N? 15. Do you have P? It is 0.4. You can do 40 over 100 if you like. That's 40%. That's fine. All right, so if I multiply that out, that gives me 6. Is that what you got? All right, so that is 6. So if I pull a random sample of 15 people, I would expect 6 of them take public transportation, subway, bus, something like that, to work. Now, it asked me to find standard deviation. I'm going to use my variance formula to get me started on that. So variance is N times P times Q. So N we said was 15, P was 0.4. In this case, Q is 0.6. That's the people that don't take public transportation. Okay? Well, this is already 6. We did that in the previous problem. So 6 times 0.6 is 3.6. Now, what is that? That's the variance. So to get the standard deviation, we have to do what? Take the square root of it. Okay? So help me out. You've got the calculators and stuff like that. Say again? 1.897. Okay? So this formula gives me variance. To find the square root, the standard deviation, which is what we probably want most of the time anyways, we have to take the square root. It was different in the calculator, right? The calculator gave us standard deviation. If we want to find variance, we had to square it. Okay? So that's what you're doing on that third page. So right now, I'm going to give you some work time. Okay? You got work time. I'm going to give you about 30 minutes to work on that next little segment in your homework. All right? That's page 599, 600, and 602. 599, 600, 602. I'll put it on the screen, but it's probably best if you have it